Okay. Um, so the goal of the session, we're working in obviously the wine industry. In this particular session, we're talking about the three-tier system between winery, distributor, and then retailer, restaurants, wine shop type things. One of the biggest things that we come across and we really need to take a look at is using things like Excel. Why Excel? Because we already have it on our desk. It's something we already can get our hold of and learn a little bit at. I use low cost. Nothing is ever free. You need to spend your time on it. But the idea is it's available. The other thing is you probably have data around your systems and available type things. The biggest problem that we see is framing the question. If you know exactly the question that you have, you can find the data to answer the question. But the idea is saying, okay, I've got a bunch of data. What can we figure out? Well, that becomes a hunt. That is very difficult. So basically, some of the things I try to guide you through is framing the analytics question. And of course, the use of data. The idea of saying, okay, how much data do we really need? Or is this good enough? Or what is this telling us? And maybe we should go dig in a little deeper. And of course, working through some of the terminologies as we try to bridge the gaps between wine and analytics. So putting these together, kind of coming up with just key decision points and examples to be able to use from so that you can actually utilize this for building customer engagements and or loyalty with your distributors, with the retail locations. And then basically looking at the wholesale operation through mathematics. That's the goal of analytics, being able to say, okay, it's a lot harder. When people say, I think, everyone can offer an opinion. But when you say, okay, here's the math, here's the numbers where they came from, this is where we think we should go, it's a lot harder to argue over math. So before we get too far along, give you a quick introduction about myself. I am an importer and a distributor based a little bit away from Sonoma, not too far, out in Dallas, Fort Worth. I specialize in Italian and French wines, some of which I have full USA representation. Others I just bring in to the local region, depending on the agreements that I have between the wineries and myself. So everything I do, I work in analytics, considering which wines I'm picking up, which restaurants I'm picking up. How do I approach things? How much inventory to have? What's my inventory turnover? When do I potentially need to put in my next order? Everything is all about analytics, because what I'm trying to do is sit in the middle between the winery and the retail location and understand the time delays between I need a bottle of this wine for this retail location. How often does the retail location need a case of this wine? Yeah, okay, it's 6 weeks in this location, 8 weeks in this location. They need 2 weeks to prep it. Putting together all the stuff mathematically so that I can actually plan orders, plan revenue, plan payment streams, and balance it all out using math. And of course, the funness of actually working with wine. I do also teach at the universities, in graduate and undergraduate level in analytics. I also do business analytics for commercial, not in the wine industry. It's technically in the aerospace markets, where we actually do the same type of thing, analyzing data, taking a look and seeing what's going on and making decisions based on it. And then overall, my background, I have a PhD in artificial intelligence and an MBA in finance. And obviously, I spend a lot of time putting the two of those together to solve business problems. And I like to run, so I figured that was a good picture to put up there, a little less formal. So let's talk a little bit, give you some terms. We'll use them throughout the time. And if you have questions or perspectives on things, again, type it in the chat window and we can pause and talk about them some more. So I pulled from Wikipedia analytics. So the key thing with analytics is taking data and then turning the data into decision making. So obviously you need to communicate that with somebody, but the idea of saying, all right, what are we trying to do? We're trying to take all this data, all the sales data from last quarter. What does it mean? What decisions do we need to make? Do we just want to look at a pretty picture of plot lines Okay, that's fine, but that's not really what we're into. So when it comes to doing analytics, there's three different types, and we'll go through some examples throughout the webinar of each one. One is descriptive analytics. That's taking a look at what's been done in the past to analyze what's been done in the past. So the idea of saying bottle prices over the last 10 years, that would be descriptive. Now, if you were to take those past history and then try to predict what the bottle price will be next year, now you're into predictive analytics. So the idea of being able to look forward or backwards in time and trends. And then the idea of prescriptive analytics is you actually have to make a recommendation about or doing something. So if we think that the bottle price is going to be here, we should buy less or buy more or buy early or do something. That's where the prescriptive part gets very interesting. But to do that, you need to understand the trends, the past and forward trends and what's going on. So as I've alluded to and we'll talk about throughout the entire time is framing the question. You don't need a lot of data points to actually say, are we more profitable or less profitable? Okay, so you wouldn't want to do 50 years of data for that. On the flip side, if you actually have two data points, there's not a lot that you can do in terms of if you have last year's and this year's revenue numbers and someone says, where are we going to be in 5 years? I wouldn't venture a guess. That's not enough data. Why? So some of it's statistics and some of it is how much data is available. So when you go to answer the question, part of the thing you really want to do is verify and validate the data. We're not going to do much with it today because I'm going through some of the process, but the idea is you want to take some of your data and use it to say, okay, does this model actually work? All right, we left out these 4 data points and then we built a model and then we went and tested the model on those 4 data points. Okay, so that sounds pretty reasonable. So now we can answer the question that was posed to us. So regression. Regression is a statistical process for determining a relationship between variables. The simplest example I use is, there's a 1-to-1 correlation between birthdays and age. For each birthday that you have, your age goes up by 1. That is a regression model. Very simple. There's a relationship between birthdays and your age. The more birthdays you have, the older you are. Okay, that's very much the sort of the same process, and we're going to try to look for these relationships in things a little more statistically significant than birthdays. We're going to do it in Excel. I said we've got Excel available to us. There's a lot of other ways to do it. I actually spend most of my time not in Excel, but the idea is when you're doing some of these type of problems, Excel is fast and easy. You can imagine if not explaining it, it's something you can throw together in a few minutes to be able to do it. Whereas the bigger complex models, Excel does run into some limits. So the other topic is data segmentation. So it's dividing and organizing your data into groups so you can sort through it. They say view it more easily, but basically make more specific use. One of the ways that very much data segmentation is used is for monthly data. Is there a trend, a seasonal trend? Do people buy more things in the spring versus the summer? What happens in January after Christmas? Do people buy more things from this particular zip code? That is data segmentation. So we'll go through some examples of that. So how to duplicate what I'm doing? There's 2 methods, and I'll be using them. So we just wanted to give the introduction now. One is what's called Excel plotline. You can take the plots and add the trend to it. And then you can do some analysis using this trend line function, which goes off and gives us some statistical data. So that's the first one. It comes with your Excel, pretty much all the versions for several years now. The second one is what's called Solver. The data analysis is something that comes with Excel. Solver is something that was added in. A lot of Excel versions come with it by default. I'm running a Mac, it did not, so I had to install it from solver.com. And you can do some optimization problems with some of the solver functions. So both are pretty useful. The solver, there are free versions of it. So pretty much everything I'm trying to stick with are things that you just load on your machine and keep up and running. The sessions, feel free to ask questions because there's a bunch of topics and I kind of move from topic to topic because it's all pretty exciting. I will bounce back and forth between the PowerPoint and bring up Excel. So there's two tabs in Excel. One is basically the problem tab, and then there's the answer tab. We'll take you from the setup and provide some of the answers. Obviously, if you want to try this again later, it kind of helps to bounce back and forth yourself. You can, oh, that's what he did. Let's go do this. Or, okay, did I get what he got in terms of that? All the data is provided, everything that we're going over, some of which is, I'll try to give you an idea where all the data came from. On purpose, the sample size and the data that we're dealing with is very small because we're not talking about trying to make sure we have the best model to do a particular problem. I'm trying to show you how you can use the data to solve a problem. So normally what you would want to do is pull about 60%, 80% of your data and run a model. And then keep the other 20 to 40% and then use those to test the model. There's a way to split off data. You can randomize it. You can do various things. But the idea of saying, okay, how do we know if the model's any good? So this is what for all the examples that we're going to do except one, which I actually do have the validation answers. Well, I just go ahead and pull all the data to build the basics for us. But it's always keep it in mind is if you've actually traced the line, it works well for tracing lines, but that doesn't necessarily help your artist capability is the best example. So when we talk about regression, regressions can be represented by relationships. The most straightforward relationship is a line. For those people into the math already, y equals mx plus b. It doesn't get much more simple than that. For each birthday, age goes up by 1. So age equals birthday times years. So, all right, it's a straightforward relationship, and surprisingly many things that we deal with in our lives are well represented in a short span over a linear relationship. So certainly you think about stock markets over 5 and 10 years, that is not a linear relationship. But you can actually break out stock markets into sub-elements, days, hours, where the relationship does tend to be pretty linear based on something. And the hardest part in that whole analysis is what is that something? So our goal is to find the most efficient line that represents what we're trying to do and expand it from there. So most efficient, we'll go through and the examples will make the most sense, but the idea of saying is how close is our line to the data points that we have. So we're going to start off with our first example. This is a sample Napa type winery, and they're bottle pricing for these approximately 10 years. So the questions, of course, we want to ask ourselves is, what should the bottle price be for 2018, maybe 2019 or 2020? Based on this little bit of data, we'll go ahead and do it a little bit further, but it would this small amount of data, this simple type of things would not be very good at saying what's the price of this wine in 2030. 2020, maybe 2021, we'll do it a little further than that. But so what are we trying to do? We're trying to say the relationship between the year and the bottle price. So we want to see what's the bottle price times the year, because then we want 18, 19, 20, something like that, times some constant, some value that the system is going to provide for us, and a constant. The constant just helps get us in the ballpark in terms of things. So this is a linear model. You know, the question is, what's the relationship between the year and the bottle price? So we can run this in Excel. So let's run it in Excel. So here is the year and the bottle price as we've done. So what I always like to do is let's grab the data and let's plot it. So pretty pictures always help us understand what's going on. Okay. So here's our bottle price over this 10 years. And if you kind of look at it, we could draw a line that might approximate it. It does look fairly linear, but it was $5 change this year, $3 this year, $3 this year, $1 this year, $1 this year, $5. So we can't just, sort of guess in terms of that. So let's let the system go off and tell us what might be the relationship between the two. And not all of them are going to be perfect because we only have a line to work from. So what do? So we go off, we select what's going on, we go to our data elements, and we go off here to the area that I was talking about and said, it's not there. Normally you have to turn them on the first time you use them. Go wait for the little spinny wheel. And that's funny. My wheel's spinning, yours isn't. Okay, now I get to wait. So we want to actually go do regression. So regression analysis. And so what it is we want to take as our input the bottle price, including our labels. So this is our Y part. The bottle price is equal to the year. So we highlight those and put them in. You could manually type them in. I click labels because I went ahead and included the labels. And there's a lot of things that we can do on this. We can do some plots, which let's go ahead and do the plots. And where do I want to stick the output? So pop that down and out of the way. So all I'm trying to do, what I was doing here was I just selected an area for it to send the output because I didn't want to do it on a new tab or send it somewhere else. So I just go off and let this run. And so we've got a bunch of data. And now I've got the screen so big that it's kind of hard to see. But if by the way, if you're running this some other time, that here is the answers all out and shown what I did and what I clicked on. So I realize I bounced back and forth. So there's a couple of things that are important that this system gave us. So let's start with this area here, which is what's called R-square. R-square is a statistical method that provides how well did this model cover the data. And it's a function of how much error there was between what the model said for each point and what the actual numbers are. If you're curious and scroll down, here is the answers. This is what it thought for the first observation and how wrong it was. So you can see the numbers and how close they were. Not too bad in terms of $2.3 off on one thing, not so great. And what I went ahead and did is had us plot. I thought I did over here. Let me zoom out a little bit since we no longer need it quite, such a heavy, there it is. All right. So if you take a look at the two different displays, the orange and the blue is the actual numbers and the orange is the predicted one. The orange is a straight line and there's a few points that you see above and below. Sort of a macro scale here. We could zoom in and take a detailed look, or we could use this, which actually shows us this number. Okay, for 2009, we were 19 cents off. For 2011, we were 14 cents off. And here's our $2.30 off. This is how good or how bad our model is. And as you can kind of see, it's a pretty good model. So that's good to know in terms of mathematically. But here's the important part. So the intercept in the year. So back to our highlighting so you can pay attention to it. So the idea here is bottle price is equal to the number 5641 plus the year times 2.83. There's our answer. So what does this mean? This means that for each year that we move down, our bottle price will go up by $2.83. Interesting. So let's take a look and run this. What I like to do is use the math here because it's easier. All right, and then I'll put the formula in. Equal to this plus the year times the function of the year. And we should get a little higher number. Make it dollars because that makes sense. And then what I do is I want to use the same value in the same column. So this is actually freezes this no matter what we do. So you can just cut and paste it. And now we have predicted amounts because our data only goes from here to here. And now we've estimated what it's going to be from here to here. So we'll go ahead and plot all the data now that they're looking together. And you can kind of see our bumps along the road for the first 10, and then it went smooth. Why? Because it's a simple model. If we did it forever, it'd be $2.83 per year as it moved forward. So just to give you an idea, this is what we did. Here's the data, X and Y. I wrote it up there as years, bottle price. We did the regression. We selected the Y and the X. In this case, just stuffed it over here. We have an R squared, our coefficients, and plotted it out along with these various data. So that's kind of, that way if you wanted to run this again, this is how you would basically duplicate what's going on. While I'm doing this. All right. So that takes care of that. Now, let me get back to the right page here. Since we switch machines. And for those people that are curious, I still have the wheel of death on Excel on my other machine. So great. All good. It's all part of the fun. So how do I do this? We can do lots of information with just this simple mathematical model by actually going off and saying, all right, now that we know what 2018 is, what would our 2020 vintage be? Well, I ran one of the times I ran it was $75.23. If we used another Excel function called net present value and said, we assume there's going to be 5% inflation per year, because remember, this is 2018, then there's 2019 and 2020, was the question, what would our 20 vintages be 2 years ago? So if we ran this calculation, it would come back at $68.32. So it's saying in 2018, if we had $68.32, that'd be the same thing as having $75 in 2 years. Okay, so conceptually, if we pre-sold that 2020 early, because many times the wine sits in a barrel and waits, at $70 a bottle, and go, okay, you can buy it now for 70, or you can buy it later at some number, which will probably be higher than 70. You actually, the winery gets more cash that they could do things elsewhere, would be higher revenue than waiting until 2020 and selling it at that point. So how do you know that number? You ran the mathematical model and said, this is where we predict it to be. So just the price of a bottle for those 10 years is just one aspect. So there might be some other ways to compare and contrast what's going on. So what I did is I went off to some websites and looked and said, okay, how does this compare against the industry standards? Because that's always an important case, and more than one reference point always helps what's going on. So I did the same math model, the same data points that we worked on before, and here they are. Here's the model running the straight line and some data points that don't look as clean. It's not as good as what we had for our particular example. And you can see it went from roughly $36 to $40 over that same time frame. So we ignore the y-intercept because it's just a number. But again, we take a look at this one to be able to analyze 28 cents a year is how it increased. And you notice this R squared number that I talk about is still good. If it was 10 or 10% or 20%, that might be very suspect, but it's a pretty good coverage of the data, and you can see which data points are not particularly holding that well. So, but you take a look and say, here's the two models side by side. We went up $2.83 for each year, and the industry average is 28 cents per year. So we're going almost 10% above the average. Is that good or is that bad? Well, first of all, it's factual. But could it be that we're starting to price ourselves out of the market, or we're turning to something, of concern? So do keep in mind that the winery in question went from $40 to $68 a bottle, and the industry average went from $36 to $39. So we've got to, certainly when you take a look at that, we need to say, okay, what does it mean? All right, so again, went to another report, tried to take a look at this and say, okay, the volume of shipments increased 1.6%, which was trailing, but a 7.1% increase in the average price per bottle shipped. Triple the price increases of the channel as a whole. So 7.1% increase of our $68 would indicate that we should be rising higher than that. 40 would be less. So we're kind of in the middle. So it's an interesting number in terms of that. We're just this particular winery is way above average. It'd be very interesting to actually pull one that was very much below the average, $8, $9 range. Do keep in mind, some of the wineries that I work with haven't changed the price on some of their wine in 4 or 5 years. So they've just left it constant. So that would, if the winery was selling wine at $6 a bottle, that would offset a $68 bottle quite, dramatically and bring it back to the average. And it's okay. Some of the wines are above average, some are the other. So how do we make this stuff more accurate? Well, we also had volume in that previous metric or index. We've got, in this article, this, ratio of grapes made to sold, total units sold, total tonnage produced. There's a lot of information within the winery that would be available to also see whether or not that helps or hurts this model that we built. Because when we put together that y equals mx, there can be multiple things in there. We can have not just the year in there. We could have the year times X plus the grapes made times Z plus something else, and let the model come up and figure out how do we put all that together. So it is interesting in terms of that. So when you start adding in some of these questions, you can throw in anything you want to. I've seen all kinds of really interesting studies that don't always make sense in terms of, your political affiliation and the type of wine you drink. Okay, that's probably overreaching. Don't know how well they've got their sample size, what kind of real data they have. But keeping to our things and trying to keep the answers realistic to what's going on, if you add a variable in and that R-square number doesn't change significantly, then we don't use it. It's not adding any mathematical additions. And that's part of the thing that people try to make statistics say whatever makes sense. Try different combinations. Sometimes you get surprised. I get surprised all the time of interesting relationships between inputs and outputs and one wine or another wine. And always before you actually take it off your desktop and say, does this answer make sense? We've kind of gone through the bottle pricing and said, okay, the answer makes sense. We are definitely one of the higher priced wines on the average, but yet our ratios, even though they're growing better than average, they're not out of some of the ranges of what's going on. Obviously, it almost begs more questions, which is, where's the ceiling? How far can we go? How long can we continue to grow at better than average? But again, we don't have data to support that question. Those would be other things that you might bring in, say, for instance, consumer pricing, consumer revenue, how much percent of their money are they spending on alcohol and things like this. So many times the idea is focus on the question, get the data, comes up with a new question, start the whole process again. But at least the idea is you're being able to understand what you have and where you're going with it. So as we do with each of these examples, we can plot them. And in a few seconds, I'll show you some examples of actually how we get this trend line. But you can kind of see based on this trend line, that if you ignore the ups and downs and kind of look at overall, this vendor number one is growing. They're very up and down, but they're growing in a relationship, in the revenue, sorry. But if our model is showing that R squared is 19%, which means it's not particularly that great. It's right at the level where do we trust the absolute numbers? Probably not. Can we trust the trend? Well, I can look at the trend and you could look at the trend and say that they're growing over time. That part's fine. If you look at the second vendor, they're kind of flat. They just kind of bounce between 2 and 3. Well, that's kind of what the model is showing with slightly higher confidence. So many times you can just use these to say, all right, they're flat, they're growing. So if I want this one to grow, I should invest in them. But if you looked at any given month, if you looked at this data point, you'd say they're equal. They both did 3 units of whatever it might be. At this month, month number 7, they might be equal. But you can take a look at a lot of the stuff and use some of these trending information to be able to come up with logical conclusions or logical things to go dive deeper with. So let's start talking about these vendors and distribution. Let's talk about optimization for a few moments. Then we'll get back into some of the plotting.
Peter, I have a question.
Yes.
When you talk about pulling data from the industry, what data, do you like the same type of wine, or can you talk a little bit more about, or just in general, or how specific do you have to be?
Well, the most specific would be if you, for instance, were a $50 to $60 Napa wine, and you were able to pull data from 3 or 4 other Napa $50 to $60 wines in trends and history, and take a look at what your, I don't want to call it competition because you may consider yourself a different market, but in other words, okay, they were at $50, we were at $50, they're at 52, we're at 51, that type of thing where that's the best way to do it. It depends on how accurate do you really need to do. If you're looking for trends, oh, look, Salinas Winery just raised their prices from $48 to $52 on a particular wine, which we consider ourselves competition with. Should we move ours up? Also, how has theirs been trending? How has ours been trending? But that's just potentially one aspect. So that's the sort of the ideal case is apples to apples. Obviously, we just went through one which was the average of all wines compared to a specific winery. So I wasn't expecting that it would actually be the same, that close in terms of that. So does that sort of answer your question without trying to give you the exact answer, because it really depends on what question you're asking yourself?
Yeah, I was just trying to get a sense. Yeah, that helps a little bit.
I do it all the time in terms of any type of analytics that I can get, because obviously most distributors don't share all of their, how much do you get from this restaurant with other distributors. So you kind of have to interpolate what you see, what you perceive in terms of their trends up or down. Fortunately for myself, I have a great working relationship with a lot of my restaurants, and they actually do tell me what the others are doing. Not because I can affect it, but the answer is they understand that I care about the analytics. So, but yes, absolutely. It's a great question. And the closer you can get, the better off you're going to be. But usually you got to start with something and then say, okay, is this data reasonable? Yeah, all right. Our numbers seem reasonable. It'd be nicer if we had this, but we don't. So Okay, so distribution. So you can think about this in many different ways. This is basically an optimization problem. If we had 2 warehouses that we own and we're sending to these 3 distributors, and our shipping cost is $6 from warehouse 1 to distributor 1 and $4 from to distributor 1 from warehouse 2. For each of these, you could manually go through and figure out the cheapest way to ship things out this week or next week, that type of thing. Where it always becomes interesting is when we start having constraints. Warehouse 1 can only do 100 cases a week. Warehouse 2 can do 200 cases a week. So let's put this together and say, next week, these are the 3 orders that we got. I put this again so you could see it with our constraints. How do we optimize who goes from what warehouse to what distributor? We could manually go through this, but it'd kind of be nicer to let Excel, take over and do its thing for us. So here's the problem. It's still pretty readable. It's getting a little small, but it should be pretty readable. Let me zoom it up a little. Okay.
Yeah, that's better.
All right, that's good. And so here's our cost that we had, and here's the constraints that we were given, and here's our order. This is just giving it all in data. So what are we trying to do? I'm trying to minimize the cost. So let me put this, I'm gonna minimize the cost. We'll go through in a second. And what do I get to fiddle with to minimize my cost? Excuse me, what goes to what, from what warehouse to what distributor? All right, so let's fill this out so it actually can be solved. So if we're trying to figure out what's going to distributor 1, we just get to sum up what goes on in this column. And great thing about copy and paste, we now have this plus this equals this, this plus this equals this. And this one must equal this. This one must equal to this one. And this one must equal to this one. All right, so that way they get what they ordered. And if we sum up everything warehouse 1 is doing, it has to be less than 100. And in this case, this one has to be less than 200. So hopefully this is making sense on our constraints and sort of what we're doing. I don't know if everyone's really familiar with this other this other term. We'll put it up there, and then I'll explain it just in case once I spell it right. Sum product of this times this. Okay, so what sum product does is it says, give me a bunch of cells and a bunch of other cells. So D4 and D20 are the first ones. So what does it do? It takes this one times this one, AKA the amount that we sent to warehouse 1, from warehouse 1 to distributor 1 times its cost. And then we add to it the next thing, which is this one times this one. Then we add to it this one times this one. Then we add to it this one times this one. And we add to it this one times this one. So instead of actually typing all of that out in one thing, we can give the groupings. You could do it all the way across. You can do it in various things, and it figures out 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5, 6. 1 times 1, 2 times 2, 3 times 3. So that's the basic function, but what that does, that gives us the actual cost of what we're trying to do. So let's make it a cost, by the way. So we could actually put numbers in here and it would automatically populate what's going on. Well, once again, let's go ahead and let Excel solve it for us. All right. So we set our objective. This is why I put it in green, and we want to minimize it. And then we're going to change variables. These. Press return. So now we've got those. And now we want to add the constraints that we're talking about. So first constraint, we'll start with this one has to equal this one. Okay. The distributor has to get 55. And then this one has to get 65. This one has to get 75. This one has to be less than or equal to 100. And then this one has to be less than or equal to.
Trying to figure out how much you should send to your distributor each
Hmm.
week with your constraints, because they only can have 100 cases a week. You know.
Yep, that would be correct. So here's our constraints. So, I mean, I don't realize I typed in quickly and they are in the solution over here too, in case you need to be able to look at it. And so basically we're saying that if I order 55, I need 55. If I change the number, we'll get a different answer. They need to get what they ordered. They need to get what they ordered. And then here's the capacity constraints on these two warehouses they can be able to solve. The rest of it we can leave alone because we're just trying to solve it. And then we basically go off and let Excel optimize the answer, come up with a solution that minimizes this cost. So we hit solve. Oh, set objective. I must have typed something in there. All right, I hit solve. And so it'll say setting down here at the bottom, setting up problem. And I usually get a few moments, 19%. Might or might not get a little wheel, but you can see it's trying to optimize the answers as it goes through. And if this is a large optimization problem, this could take a while. And you could actually see all kinds of interesting numbers. And it says, I found an answer. And we can get some reports on how good the answer was. But the idea here is it solved it for us. We got 55, 65, and 75. And it cost us $845 to shipping costs to get these units out. What's going on? All we have to do is we could change this number, to 70 and rerun it. And we'll get a different answer. Potentially, you could just shove it right down there, but we don't know in terms of what's going on. But this is really cool. You can let it do all the hard work for you. Because all we care about is minimizing the dollars. What happens if our shipping cost changes? What happens if this happens, if that happens? Just take it and hit solve again. Let it rerun. Kind of cool. So, like I said, I realize these kind of go quick in terms of that. And obviously the shipping problem is pretty straightforward because when I go through and do deliveries on different days, do I do a delivery to one place and home and another place and home and that back and forth? Do I optimize them in different methods? You can put the cost of doing different routes in there and let it do it. The same thing you could actually mathematically figure out it depending on how many tons of different grape varietals that you have and or produced. What kind of different blends can you make? And then of course you can take that in terms of feeding that back into some of the linear model we did in the first one to figure out how much money you can make. I mean, it's not really how most places are doing business because you enjoy the wine, because you make the wine type of thing, but you could actually figure out based on how many dollars per ton or dollars per bottle you get for your Merlot or your Cab, or your blends, how much should you make of each one to maximize your profit? So there's an optimization problem that's pretty straightforward in terms of doing that. Another aspect of it is actually the cost function. The $4 shipping, the $5 shipping, you can actually run different, what percentage of activity should we do to be able to say, should I insource this or outsource this? If I hire someone to do it at $10 an hour internally, or I hire this team to come in and do it at per task costs, you can run these optimization problems because you always think of things as it's either or. We either insource or outsource, but what if we actually supplement for a particular time? How does that affect? What's the optimal way to do it? This is the type of function that we actually use to put it together. So it's usually pretty exciting in terms of that. So on to the next topic. Now we get to talk about the trend lines to be able to put in it. Which one's your favorite Excel function?
The one that you just did, the optimization.
Oh, okay.
I like watching the number changes.
Oh, okay. Yeah, well, maybe some other time we'll put together something where you actually get to do machine learning and get to spit out numbers for a couple of hours of all the things it's learning and doing. But yeah, it is interesting, and it is, depending on how complex, and that's why I didn't want to go through and get the simple example. You can get them to actually spin around numbers and watch things. So you do have to watch out occasionally and hit stop, because it's like it's trying to optimize 25.5 versus 25.4, and it can't get the type of thing. But it is really exciting to be able to set it up and do. So what this is, the specific data is Italy exports, France exports, and Spain exports for several years. But obviously, this could be sales per region. It could be many, many different ways. We want to go take a look at it in Excel. As soon as whoops, all right. As soon as I actually stop this and get Excel going, back up again. All right, to the next tab. All right, so let's take a look at this data and try to keep it simple. So I'm going to take a look at this data, and then we're going to insert a graph because we want to take a look at this data. All right. So now that we have the data, we click on the actual plot. You can see the data, and you can technically edit the data if you needed to directly in the thing, but we're not going to do that. What we're actually going to do is right click. It's going to ask us to add a trend line. So it's a very powerful capability. And so what it does is it adds this trend line. I'm going to scoot it over so it's all visible. So not only we can see this, and you can kind of see that this line looks representative of what's going on. It's not perfect, but it's interesting. So let's go ahead and put these on here. And this is the part that just takes a second because I want to make sure everyone can see it. All right, pop it up here, pop that back down. All right, now we're back to where we were. And yes, okay, good. So if you take a look, this is the same type of formula that we've been working with. It has some y-intercept and 0.8. So the value goes up every year, 0.8, whatever units this is, millions of tons, millions of dollars, which really isn't the point. And we've got about a 36% coverage. So the model is okay. It's reasonable. And again, what are we trying to do? It's clear that they're trending up. So if that's what we're looking for, the data is great, or the model is great, because that shows us it's trending up. So we basically did the same type of thing that we did with our other activity. We don't get to see what the residuals are for the up or down or any of the other statistical methods, but we get the summary information. So this is where you would decide, do I need more of that? Or is this good enough for what I'm trying to do? It, again, depends on what problem you're trying to solve.
Peter, can you talk just a little bit more about what a good R-square is?
Sure. So basically, an R-squared that's 1, it means that the model you built covers everything completely and there's no error between the two. So if I plotted a straight line, if I gave you data for a straight line and then built a model, the model should be a 1 or approaching 1, which means that the model represents the data. Doesn't always necessarily mean that's a good thing. Usually if you have an R-squared of 1, that's a red flag that something's wrong, like you've what's called overfitted the data. If I actually were to build a model that was just these 2 points here, I could perfectly represent it. But then that's all I can represent. So the line would continue down this way. It wouldn't be particularly good. So the idea of a high R-squared better than a low R-squared, a 0 means our model is terrible, it doesn't do anything. So it really depends on what you're trying to see. how I like to describe it is we've got about 36% coverage. So is that good enough to answer your question? Well, that goes back to your thing. Can you answer that, or is that good enough to be able to say, yeah, this is what we believe? Or would you rather have the number in 60 to 70% range? When you're talking to statisticians who are trying to put together models, they shoot for that 60 to 70 range because they have all the data. If you don't have all the data, if this is all we have for Italy, okay, we can draw conclusions from this data right now, which is we're trending up. And we're trending up roughly at whatever 0.8 per year is. That doesn't mean next year it's going to be perfect. I don't know if it's going to trend is going to go down, then we'll be way off, or the trend will bounce back up. But again, it should be within, I use air quotes, within reason of what's going on. And when we start getting much below 20%, the answer is the model's not accurate for doing any kind of conclusions. So big picture. So does that kind of make sense? It's not an absolute. It's not like, oh, when you break 80%, it's going to be great. Well, it still could be terrible at 80%. But
Okay, that's great. That helps.
okay. So this next part may actually even help a little bit better. So the cool part with this tool is we've been talking about a linear model. There it is, y equals mx plus b. Right? There's other type of models that exist in the world. There's an exponential model. Okay. You notice the R squared isn't any better, and the model's okay, about the same right now. We've got a logarithmic model. So it uses the log function as part of it. Again, we're not going into any details, so don't be too stressed, but look at its R squared, it's worse. Not a great model. We'll go to the polynomial last. We'll do a moving average. Moving average can't have it because the way it's done. Power function, there's our power function, but again, R squared is pretty bad in terms of that, and the polynomial. So you go, well, wait a second, ours was 36, and we added one more thing. We actually took the value and squared it and made a function out of that. Now we're at 47%. Hey, wow, we what, 36 to 47%. Okay, that's great. Now we're at 53%. So your next thought is this: we should use this model. It's got much better coverage in terms of what's going on, right? Not necessarily. We've got this other thing called let's forecast forward 5 periods. Let's see what the model does in the next 5 periods for exports. Do we really think that Italy's going to do this? Probably not. Okay, it just doesn't seem reasonable in terms of this type of data. Could it be? Yes, but this is an example where I'm beginning to overfit the data. I'm so obsessed with trying to get this number higher that I'm like, oh, wow, let's take a look and see what happens if I do 4. We're not going to go negative. That just doesn't make any sense in terms of that. I mean, okay, we're not going to rocket like this. But you notice each time our R squared is moving up, quote unquote, significantly, but we're trying to chase the curve is what's going on. So let's go back down and say, okay, could this be trending? Still seems a little aggressive to me. So that's where we go back to the linear model and say, okay, even though it only has 36%, the answer probably is somewhere between this model and this model, which is just the one added function. But honestly, if someone were to say, what do you think is the best model for the data that we're looking at? I'd stick with this one. Why? Because we only have 12 data points. You would see a better fit if we were to have 100 data points. So yes, this is exactly how you do it. And I don't think, did I actually plot all 3? Yeah, okay. So I don't want to spend too much time, but if you actually take a look at these, look at the trends. I realize the data itself is a little hard without me zooming in. Let me just see if I can do this. Nope, still doesn't make the numbers any bigger. But so if we take a look at the orange, which is France, according to this, France is trending down. Are there exports going down over time? Possibly. So you go, oh my gosh, look, you know, they're trending down and they're trending up. Spain's going to catch France at this rate, right? So if you were to just look at the trend lines without taking a look at the data, you say, wow, it's only going to be another 5-10 years and Spain's going to catch up. We could actually plot them. I mean, extend the, do this on the thing. Let's go forward 10 years. And let's take this one and let's go forward 10 years. Look, in 10 years, France and Spain are exporting the same amount because one's going up and one's going down. I'm going to put this back so you can actually somewhat read the numbers. But if you take a look at this one, its R squared is 0.08. That's really, really low. And this one is 0.01, 1%. So that means we've got a large error in our model, but that's the best that it can do. Because there's so few data points and there's so few things, we get such a low R squared that, arguably speaking, we can't tell anything about the data, even whether or not one is increasing or one is decreasing. But with the Italy one, it's decent. That's why I use that one as the example to kind of show you how you do it. But don't be obsessed with chasing these R squared numbers all the way through. Otherwise, you'll end up force fitting what the data you have, which will mess up the data that you don't have. So hopefully that gets you a better idea and also gives you a pretty good feel for what kind of tools that are available for actually doing these models and relationships between the different input parameters and output parameters. So back to Excel. All right. So use the simpler model whenever possible. You know, how much coverage do we have? Is it a reasonable R squared? The solver does give you an error function. We can look at that. But the idea is many times you get done with this and you go, wow, that's really cool, but I need more data. But that's great. Whether or not you hire a consultant, a university student, or a giant company to go answer questions, if you go, here's my data, what do you know? That doesn't actually help much. But once you say, look, based on this data, this is where we think we're heading. What do you think? And that's where they can earn their keep and value in terms of, okay, well, we have this extra data, we have this, we can look at this, we can put this model together. But if you don't know where you're going, it's like, you know, trying to drive in the dark without the headlights on. It doesn't really help. So understanding, at least in the ballpark of where we're at with these simple tools, takes you a long way towards answering a lot of these questions. So data segmentation is a really interesting part. Hopefully it'll make sense on how we set it up. Obviously, not all distributors are the same. Not all distributors same value, headache, or maintenance requirements. Yes, you can quantify headache of your customers and put it in a math model and do something about it. So how do we segment is useful. Should we just leave things alone based on a trend or grow or drop? Excuse me, a vendor. So the best way to talk about data segmentation without going through each of your specific data is doing things on seasonality. So you can think, what do people buy in the spring versus buying the summer versus, you know, that type of activity. So the idea of saying we have some revenue, all right, this is period 1, 2, 3, and 4, quarter 1, 2, 3, and 4. This now is the data segmentation. So quarter 1 data, everything that's in quarter 1 data would have a 1 there, otherwise a 0. Everything that's in quarter 2's data would go here. Quarter 3's data has a 1 under its column, everything else is 0. So this is where we talk about my data being very simple, because I'm trying to get the point across. If you're really going to do this, you should have more than 1 year's data. You should probably hopefully have 5 years or 10 years or so of data, because then when you start looking in this column, there's only one data point. right now. There's only one data point, one data point, one data point. So the model is going to be artificially good because it's not hard to model one point. It's that point. But the idea is we're trying to see what is the quarter's contribution to our revenue. So here it is plotted out, you know, in terms of how we're plotting things, and we can run an analysis, and this is what we're going to go do. But you notice the error is 10 to the negative 11th power, which is almost zero. Might as well call it zero. All right, wow, wait, that's really cool. We've got a model that looks interesting. Here's our data for this year, and there's what our data is going to be next year. And our R squared is 1, which is what I told you is a big error, big red flag that you've overfitted the data big time. Because what are the chances that our next year's quarter is going to be exactly like this year's, except better? Probably not. Will it be similar in nature? Yes. But will it actually be the same? No. So let's take a look at this and put it in the system in a little bit more detail so that we can go off and put this. So what I did is I have 12 months of data, and I took it all the way down to the month in this case. So let's take a look at where things go for the month. So anything that's in January's goes here. Otherwise it's 0. Same thing for February, for each month. And then the only thing we have left to add is our calendar, our sequence, because we care about the revenue going up or down over time. So this is just time. It's just my reminder to not forget doing it. So what we're going to go do, come back to our data analysis, and we're going to do regression. Now our regression, what do we care about? We care about looking at the amounts. And then we're going to take all of this data and see what its contribution is in terms of what's going on. And I want to stick it over here on purpose. So that's it. Everything like we've done before. I'm not going to do the plots because we already know that the answer is, wait. Why did I not do that? Hold on a second. That's that. That's okay. Then this one goes here. Turn. So it goes here. This is what happens when I go too fast. Okay, so this is what I was saying before. Our R squared is 1. So I'm not even going to highlight it as green. I'm going to put it as red because that is a warning to ourselves. And here's our coefficients that we've done. So let's go ahead and see, what does this really mean? So the next thing we want to do is use this model, because here's our values. Instead of having 1 now, we just have 13 of them. So what do these actually represent for the next couple of months? So yes, there is better ways to do this. And 24. So we want to see what happens for the next set of month, next year. We want to predict the revenue. So we're going to do the same thing, because remember, this is January, February, March, April, May, June, July. And what I'm doing here is I'm going to copy this data, and I'm going to put it across here to multiply against. Remember that sum product that we did before? We're going to do it again. So how I do it here is I do a paste special. And instead of going, this one was the data going up and down. We want it to go across. So I just want the values, and I'm going to transpose it, which means instead of going up and down, go right to left, left to right. See, there it is. 0, 62, 32. So it puts it right across for us. And now it's a whole lot easier, because all I have to do is say is equal to that y-intercept. And I have to make sure I take care of it later. Some product of we're looking at this row. I have to start from this side because it's covering it on the thing. Oops. And this one. All right. So
Peter,
yes.
Peter, real quick, is on you have 8 instead of 18 on cell 25. Is that on purpose?
Nope.
Okay.
You're typing too fast. We would see it in a second. You'd be able to look at it and see, all right. So what this says is, I'm going to highlight this, and this is going to be another year. So we're just going to make it blue. That's not going to be, let's make it green. All right. It's pretty obvious and you can still see it. Basically next year, this is our predicted year and this is our current year. So it's saying in January, we should grow from $46,000 to $47,000. Cool. And then we're going to copy it and see what we're going to be for the entire year. And I screw up. Oh, yeah, I screwed up. All right, hold on. This is the fun part. All right. The same thing that I just did there, I forgot to do down here, which means we want to multiply everything times this row. So what these dollar signs do, if you're not aware, is it locks in the row or column that we're dealing with, so that every time I multiply these ones times this. So that's what these dollar signs do. Otherwise, what it was doing is when I move down one row, it moves down one row. So let's take a look and say, let's see what we actually have going on here. So let's look at the data. So this is our data for the first year. I'm just going to plop it down there and say, all right, pretty up and down trendy. All right, so now let's take a look at the model for the entire time. So we're going to put that one next to it as another plot, just so it's easy to see. And what is it? Basically, our model said we're going to follow the exact same trend, but we're growing. We're growing by $27,000 a year, but we're still going up and down in January, February, March, as we would be the year before. This is an example of R squared being 1. We're not going to follow exactly month for month the same levels of spikes and drops that we had in the previous year. It would be kind of interesting if we did, but it's pretty rare that people do that. So if we take a look, I think, did I plot it? No, I didn't plot it on this one any different. So this was me running the same thing again. But what I actually wanted to do is, since we have this data, this is the line that we just got done plotting. Okay, and the blue starting here was our estimated values that we took for next year, this thing that we just calculated. And if you look underneath of it, these are actual values. This actually represents the tasting room of one of my Italian wineries. So these are the actuals for their tasting room, saying, okay, they started off about where they were trending before. First couple months, they seemed like they were spiking a little bit, and then things dropped dramatically, differently. But they still generally follow the trend lines, but you see this massive drop in the data, okay? The next thing you would go through is, why did we drop? Why have we dropped revenue as bad as the year before, even potentially worse? You don't have to do a whole lot of digging in this one because of the time frames and everything, the way it was set up. This is when they had to shut down for COVID. So this actually, they surprisingly followed the same trends, just at a lower value. So of course, you know, how did they handle the revenues and things along those lines? But this is an example of actually taking the actual data and looking against the predictive model of the 1 year. Now, if you actually take this data and run 2 years worth of data, you'll get a better model and you'll be able to see more things. We're not going to solve the COVID problem because that can't be predicted mathematically. Although you could say, if this happened at this point, or if this happened at this point, where do we see trends picking back up? In other words, if they say, okay, vaccines available at this particular point, in, April or May? What do we predict our revenue is in June or July? Yes, you can start to build models against that. But I thought this was a great example of actually saying, okay, this is the problem with only using 12 data points, but I didn't want to spend 30 minutes setting up the problem for you with 5 years worth of data that would have better trends, more accurate information, but at least get you in the ballpark of what's going on. And I said, it's always good. I could have went ahead and put 2 years worth of data and fed that back to you. But then I had nothing to test it with. Now at least we can see our model is in the same general trend, but the numbers were wrong because of COVID, but they're still following, these peaks and valleys that they followed the year before. I find it really interesting in terms of that. So did the winery. We actually went through and we did tasting room staffing. So they gave me like 8 years worth of data, and we did tasting room staffing, and I gave them all kinds of recommendations based upon what I saw, because they didn't tell me anything in terms of what days they're open, what days they order, what days restaurants work, things along, what days are customers allowed in and only restaurants serve. We were able to pull that out from the data because of being able to take a look at who sold what percentages, dollar per sale was higher on certain days. So those would trend for certain set of things. So I pulled that out. It turned out that those were the days that were retail days, and they were only open on those days. So that's why they spiked in terms of that, but yet they did higher quantities on these other days. So I identified all these without knowing what was going on under the hood. And they're like, yeah, okay, during these several days, they're not open for the tasting room. So those are all restaurant orders. So they're low cost, high volume. So that's why the dollar per sale, dollar per bottle numbers were lower than on these days, which is where customers were coming into the tasting room. And it was like the data showed all that. And they took it all back to the, to the winery and said, hey, this is pretty cool in terms of here, but being able to poke through the data and just explore, ask a question, refine, we were able to get through some pretty interesting, I think, analysis for, what was going on. The hardest part was actually cleaning up the data. I probably spent 16 hours cleaning up the data and 2 hours doing this cool stuff of actually analysis. So that don't underestimate what it might take, because someone accidentally, like I did in the example, made an 8 instead of an 18, or accidentally put a semicolon in there or something that screws up the data that doesn't make sense. But it is pretty exciting in terms of that. And as you would think, you can look at, sales per varietal, sales per channel, and then be able to put through these different cost comparisons and try to do that. And again, you can feed that back to an optimization problem and feed that back, so that you can continue this sort of round and round depending on what your goal is and what questions you're doing. Like I said, the cool part, all with Excel. I mean, I think that's interesting. So the tasting room was interesting. The data set that I gave you for this example in this is too small. The 5 or 6 years worth of data was good. They actually had it broken out per day. So that's how we were able to go through. You can easily imagine, 5 years worth of data on a daily basis was a very large data set. And that's how we're able to pull, average sales, average values per year for day of week, because there was enough data to be able to do that.
Peter, what kind of decisions were they able to make with that tasting room data?
Fortunately, unfortunately, what it actually verified was their staffing levels that they had were pretty reasonable. But what they did is, what I asked for was, hey, do you have some data that I can experiment on that would show that I can do some seasonal things with? So they sent me a couple of years worth of their data. And then I went through and analyzed it and said, okay, this is what I was able to find. And then that's where they were able to verify and validate, for instance, Tuesday, they might not have enough people in there, but Wednesday and Thursday they were good. And even though the numbers were higher on, certain days or lower on certain days because of the staffing, because of the type of customers, they were able to sort of validate their staffing levels. Like I said, on one day they said, this looks interesting, we may have to look at more people when COVID comes back now, of course.
Peter, we have a question. Diane's mic isn't working. So she's asking what variables were included in a data set that predicted a nearly 20,000 growth year over year from the previous January to this January.
So that you're talking about this data set. So this was, I mean, both this data set, by the way, is an abstraction of this one that we just worked on, which is right. Oh, sorry, that's my emails. Don't care about those. So this data set. So this data set is actually an abstraction of the daily revenue from the tasting rooms in Italy. So to answer your question, that would have been 365, not exactly, but days worth of data for the entire year to represent those numbers. And then those were run, I ran them at the daily level, but would have been too much for us to do. I ran it at the quarterly level, seemed like not enough data in terms of that. So that's why I abstracted them against this, but that's what they represent is actually, they handed me the data per bottle order. So I ordered 3 Sangioveses and 2 sparklings. So it was much more than 365 orders per year. So I took those and abstracted those per day, per order. And then I also reran analysis, and that's how I got the revenue per bottle in there, because I had specifically 3 bottles of this cost this, 4 bottles of this cost this. So that's where I got the bigger analysis from, but this was actually daily revenue, abstracted up to monthly revenue. Hopefully that answered Diane's question.
Yep, we're good.
Okay, good. All right. So back to the cool stuff. All right. So sales and correlation. So this is one of the, I think is the exciting thing, even though there's no number spinning on the screen when we get to run it, one of the most important things. So you've got correlation. It goes from -1 to 1. And with 0 being, 0 meaning that there's no correlation between 2 elements. So what does that actually mean? If you go to the grocery store and every time someone buys tomatoes, they buy a can opener, that would be a 1-to-1 correlation. If you see someone picking up a can of tomato, or even better, if someone picks up a can of tomatoes, they pick up spaghetti noodles every time. That's a 1-to-1 correlation. Okay, that's great. A 0-to-1 zero correlation is you can't predict. Generally means that they don't, but you can't necessarily predict it. Sometimes they do, sometimes they don't, but you can't understand it. A -1 correlation would mean if they pick up spaghetti sauce, they do not buy fish. Just make it, that type of analogies. But the idea of saying, okay, if you buy fish, you don't buy spaghetti sauce. And so these are valuable things to learn if you can figure out what the correlations are. Because obviously, if you're going to run promotions, want to sell more cab, does it affect my Chardonnay sales? Wow, that's pretty interesting in terms of that. So a strong correlation, a positive correlation means if I buy something and I'm going to buy something else, that's a 1. And a strong negative correlation is if I buy something, then I'm not going to buy something else. So, and then in the middle of 0, you can't tell. So then you get weak correlations in the around 0, and the closer you get to 1 and -1, the stronger they are. Again, if we find a 1-to-1 correlation, that's pretty unusual, or we don't have big data in terms of that. But we're looking for interesting numbers. So hopefully correlation as a concept makes sense. Lots of interesting things behind it, but that's the general gist of correlation. So again, some small amount of data. We've got these 8 different wines, some red, some white. Whoops. some red, some white, and some unit sales over some period of time. Again, I have extracted it. This is actually some of my data, so I know exactly which wines they are, which is interesting because the first time I did it, I did not know what the answer was, which is always cool. So here the data is just some number of months, and then units sold, could be dollars, could be, you know, something along those, but what you're doing is you're looking for correlation. So we go into the data analysis tool, we come up, we click on correlation, and then it says, what are we dealing with? Fortunately, this one took before. So we're just doing all of them from the beginning to end. Labels in the first row, so we can actually see the correlation. And then we're just going to stick the data right down below. The default, by the way, is a new worksheet, but then we get so many of these tabs open that it's really hard for me to get back and forth. I want to explain it nicely and simply. All right, so now I'm going to go ahead and zoom, because this is like really cool and important stuff. All right, so if we take a look at the wines and we say wine 1 and wine 1, they're completely correlated, because if you buy wine 1, you bought wine 1. Well, yeah, okay, that's not really useful, is it? But there's a correlation that's saying 45% correlation between wine 1 and wine 2. So I'm gonna highlight that one as a maybe, and scroll down here and go, look, there's almost no correlation between wine 1 and 4. Oh, between wine 1 and 6, there's 63%. That's even better. So I'm gonna, I'll give that one a, oops, no, I don't want to do that. Okay, hard to read. I'm gonna highlight it this way. All right, and then let's take wine 2 and wine 3. All right, I guess I should have done this way. But I don't want to do too many things that are too hard to read on the screen. So then I also want to come over here and highlight this one, because we want to talk about this one. All right, so we have a correlation here, wine 1 and wine 2. There's a 45% chance, roughly, the way it's described, that if we buy wine 1, we'll buy wine 2. If we buy wine 2, we'll buy wine 1. Okay, we don't have enough data to see whether or not it's actually both ways, but because all we have is unit sales. But they're saying there's a decent chance, a 45% decent chance, that if they buy wine 1, they'll buy wine 2, or that month. There's a 63% chance that there's a relationship between wine 2 and wine 3. But, so you think there's wine 1 and wine 2 is a decent chance, and wine 2 and wine 3 is good, but wine 3 and 1 is not. That tells you that it may not be a two-way street. So if they buy wine 1, they might buy wine 2. Or it's almost like if they buy wine 2, they might buy wine 1, but if they buy wine 2, they're probably not going to buy, 1, 2, and 3 altogether. So it's almost like there might buy 1 or 2. That's kind of how I interpret these 3 elements together, not the one. So if this was a strong number, then it would be like, okay, they like one, they like the other. The same thing here, we've got wine 1 and wine 6. That's a pretty strong correlation. It's one of the biggest that we have along the group. But here's the interesting part. Wine 6 is white, wine 1 is red. So there's an interesting correlation between that red and that white. So that for some reason, the sales of both of them are trending up at the same time. And since this is sales data, you can't actually know that it's the same customer buying both. But if our revenue for red looks like it's going up this month and wine 1, then we should maybe see a jump in wine 6. Expect to see a jump this month in wine 6. The other interesting one is negative correlation. That's why I wanted to do 5 and 6, negative 0.55. So if we see, oh gosh, wow, we're getting a bunch of orders this month for wine number 5, we're probably not going to see a good month for wine 6. Again, this is based upon this data. We give you 24 months worth of data, 36 months worth of data. The correlations may actually change if you put per vendor. then yes, you could actually get the more specific information about the vendors. But since we're only doing this as general revenue, but doesn't this become the basis for if I'm going to run wine promotions? If I'm going to run wine promotion of wine one, I should be targeting wine one and wine two. If I'm doing one for or wine one and wine six, that could be an interesting promotion because you're already seeing statistically speaking that when one increases, the other one is going to be affected also. But if you're going to do one on wine one and wine six together, you expect wine five to go down. So depending on what you're trying to do that one, this becomes a good starting point. So yeah, if you break it out per consumer segment, per distributor, per restaurant, and look at the correlations, then yes, okay, so we're seeing our sales slow just on our simple trend line. We want to make this revenue go up for wine one or wine two. Then we do correlations between our different wines and say, okay, let's run a special with wine one and wine two. Okay? And it makes sense why these two generally are more highly correlated in terms of one, two, and actually one, two, and three. They represent entry, mid, and premium wines of the same class. So for some reason, people like these two as a grouping or these two, but it's pretty rare that they group the basic and the premium together. So if you think it's almost like a restaurant wants to be high end or they want to be low end and they don't mind the middle one, but they don't want to go either way. So it's interesting. But these are the kind of trends that you can see. These are the kind of information that you can put together. Again, I find this the most fascinating in terms of all the things that we've been looking at in terms that, because it's like, it's the most valuable. What kind of trends do I set up? You know, that kind of thing.
Yeah, and Peter, that one is like I've never really worked distribution, but on the DTC and e-commerce side, a lot of times, you know, wineries are building those websites that when you buy one wine, you know, it has recommended products will pop up, or it'll say, you know, we recommend these products to go with that wine. So, you know, they're doing promotions in the cart. So that's another way you could use that. And I've always wondered, like, you know, how people like decide what pops up as we recommend this one if you buy this. And I'm sure a lot of it is just, you know, ones they want to sell versus actually doing the data analytics to see which ones are actually selling with that wine, which is really cool.
Right. Well, but see, you can take it. You can take it either way. You can say there's a natural correlation between these two. But say, for instance, right now there's a weak correlation at all between wine one and wine four. Okay. Or let's use wine five, because wine five, well, I don't have any, there's very weak in terms of wine five and wine two. These are negative correlations. So maybe what you want to end up doing is trying to run some promotions so that you maybe you can force it into a more neutral state, or like you said, you're like, okay, you know what, we got too much of this wine number five, so let's get it on there as a promo, and maybe they'll like it. Or possibly what they're doing is the psychology of the thing that says, clearly, if they like wine five, they're not going to like wines two or they're not going to do as much with two and three, and there might be something with one. So if you picked wine three, we also recommend wine five. Why? Because chances are good you'll like one of them. You're not going to like both. You'll be like, yeah, this one wasn't so good, but I like wine five, but you bought three originally because it was on recommendation. So they could be playing both sides of that thing, which is the whole, you know, the direct to consumer thing. Are you looking for the complementary or contrasting wines to package and bundle together? You know, oh yeah, we're going to go with verticals of wine three because we're just going to boost the sales of wine three. Or are we going to take a strong or weak correlation and try to drive it into a stronger correlation because we see that consumers, you know, if they like wine five, they don't like wine three. So we'll go ahead and send them one of each. And as their introductory packet, and chances are good to like one of them and hopefully stay with us. So yeah, it's just that this part, it was one of the most fascinating in putting together because for that reason, where it's like, okay, should I run a promo with this and that? And what's the relationship between wine 5 and 6, given that it's white and red? Yeah, cool. So yes, it makes for an interesting balance. So you could profile, as we just discussed, all the way across the board, not just distribute. Think about it: distributor versus distributor. What does one tend to buy as a grouping? Or within the structure, if you're the winery, in the 3-tier system, we're selling them in this way with this correlation, and directly we're selling them with this correlation. So that helps put your marketing plan together. Is it one varietal complementing the others, or is it sort of competing, or they like one or the other? So it's the great thing of being able to put these together. And again, it doesn't guarantee us anything. These are mathematical trends, so that we're able to go through and say, hey, I've got this. This would be a great marketing experiment. Then you get to verify and validate what you've been doing. But which wines do you start on this experiment with? Now you've at least narrowed down the groupings in terms of that. So yeah, sparkling wine versus dessert wine sales, how do those correlate together? So it becomes, it's very interesting. So when we start putting this all together, which is that's that point in our discussions, we use the descriptive analytics. What did we do in the past? What was the wine sales or the bottle pricing in 2007, 2008, 2009? Okay, what influenced it? It's basically low risk and high accuracy, because we have data points to keep our numbers on. If someone were to say, if we were going to do a mid-year price, what should we have done? Well, okay, mathematically here it is, but we have these 2 endpoints to keep us in line with. So we get high accuracy, but who cares? The only time that it might be interesting, and it's not really here in terms of that, is actually looking at the bidding wars that go on for old wines. If we actually are trying to look at the past and the future and saying, okay, we have this 2008 Caymus wine and 2009, 2010, what they sold for, what would this 2007, do we release it out of our inventory now, or do we wait a few years? So the idea of saying there's limited value in terms of what we can do, because it's looking backwards and things are sort of locked in. The correlation, the plotting, they fall into this environment. Again, it's not that there's no value. There's certainly value, but trying to understand what the price of gas was 3 years ago may or may not actually help us today. So predicting is the key area. We're trying to figure out what might things be in the future. So the idea of saying, oh, we think that sales are going to grow 10% year over year in the following year, and this is how confident we are. The R squared helps. Okay, so we believe that based upon the descriptive analytics that are going on, we then take a look and move it forward. We have many models to choose from. Keep it simple. Use the simpler model. But this is where the regression type things come into play. Obviously, when it comes in terms of the risk reward, it's more risky, because like with anything, will it be hotter tomorrow than today? Well, the weather person predicts this. Well, how many times are they wrong? And that's just a one-day prediction. So then you get into prescriptive. It's using the past, looking at the future, and then adding in anything that you really care about. And this is why we did the net present value in the very beginning. You also may have in your business, weighted average cost of capital. You're not allowed to start an adventure unless you can get, say, for instance, 10% return. Okay, so that becomes your bar. So you're feeding all of that together back into these models to say, what are the chances that I'm going to be able to grow, to be able to hit the money that we need to pay back our investors? So these are typically feeding the financial reports. Belief in the data becomes much, much more key, because we're not just saying, oh, we think the bottle price should be about $70 next year. Okay, well, if you're not releasing the bottle price until next year, then you can look at it then to decide, oh, wait, inflation came up a little higher than we thought. Our taxes are a little bit higher than we thought. So we're going to price our bottle at $70.50. Okay. But how do you do that, from a business perspective? That's exactly what you're doing through the prescriptive analytics. You predicted that it should be here based upon what's going on, but you're foreseeing based upon investors, based upon taxes or other write-offs that are needed, that you need to incorporate this and decide. It's the deciding part that makes the prescriptive part valuable, based upon math again. So how confident are you in the information moving forward? If we've done, basically this set of things that we've done gets you in a good ballpark. What gets you in a better ballpark? More data, not too much data. And if you actually take a look at, IBM's stock price for the past 5 years, you can do a lot of analysis in the short term and prescribe, should I buy or sell on any given day? You're not going to get statistically any better values if you get the last 50 years worth of stock data. Why? Because the trends have slowly morphed over time, that the data that's 40 years old is not as relevant as the data 4 years old. So this is where I was saying about the data, and believing in the data becomes a key. So there's a lot of other things, by the way, the solver can do. There's a lot of statistical analysis that's available within Excel. A lot of it's really cool. A lot of it you only use once in a blue moon. So it's always nice to know that you have it in terms of that. But I say we're sort of scratching the surface, but we are scratching the surface on each and every one of these elements. I was trading some emails with someone a few weeks ago, and they're like, "Yeah, well, you could do an entire 9 webinar series just on all these different components if obviously if people are that into math." In terms of that, because there is a lot of things and capabilities that can be done, and they said we've kind of glossed over a lot of them to give you the points so you can go off and use them. But again, it's better to defend things based on math than I think. So
Peter,
yes.
Peter, I have a question real quick. So I just noticed on your last slide that you were talking about like moving average. So is moving average something that would work well to predict revenues, or?
No, but actually it doesn't, because
okay.
what it does, because you think about what drives most of the winery revenue. Okay, in general, it's seasonally based. Okay, if you're talking a 3-tiered system, they sell much more sparkling wine and events and Valentine's Day than they do in May, right? So a moving average isn't going to help with that type of data. If you're looking for growth or trends, small short-term trends, maybe in terms of that. But the idea, that's the biggest thing that I've seen in the wine business is things are cyclical in nature. As a matter of fact, one of the restaurants I was talking to the other day, we're like, "Oh yeah, we're finally past the end of the year. We're going to sell more red wine."
Right.
Okay. Well, technically, they know that. That's local knowledge. But mathematically, you could probably put it on paper and actually show what's the red versus white trends and where do they sell, and in terms of that.
And there's another question from Dante about what other tools besides Excel do you prefer to use?
Sure. So I actually answer that in
Oh, perfect.
one more question after that, and I'll be glad to go through that in terms of that. Anyway, so part of the reason, you're doing return on investment for analytics, anytime you're trying to do things, in all the different jobs that I've had in the past, people always come to me, "Wow, how is it you can get all this stuff done? You can get our executives to spend money and invest in these things, in inventory and those kind of things." And the answer is always, I presented a business case. It doesn't always have to be a great business case. It just has to be reasonable. Hey, look, if you guys give me, 4 hours, I think I can take this data and do something useful with it. Chances are good they're going to go, okay. look, we already have Excel. That was one of the reasons why I purposely wanted to do this type of thing in Excel, because chances are good you already have it on a machine that you can sit down with and play with data. And so it's not yes, there is an investment in terms of that, but the idea of saying, okay, it's fairly small to be able to pull some revenue data and plot it and take a look at it and put a trend line on it. And what can you decide from that? Oh, that's interesting. Obviously, you can exceed the capabilities of Excel quickly, but again, you have to at least get to that point. And to give you an idea relative to running the distribution business, I do all of my inventory distribution, all of my VAT from UK, Europe, US taxes, restaurant planning, revenue expectations, taxes, all the whole 9 yards, all using Excel. As a matter of fact, do all of that in one Excel file. It's a big file, but I can just move between tabs and look at what my next planned importing is, how much it's going to cost, when will I have that revenue available to pay that, because I have to prepay in this case and I have net 60 in this case. So put all those together in terms of the functions. Now I do have tie-ins, I do run databases and external financial systems as needed to be able to get things in and out, but the core of everything that I'm doing is in Excel. So what happens if I grow outside Excel? There's free things that are available. And when I say free, they don't cost to install, but you have to learn them. Most notable two are Python and MySQL. MySQL is an actual database where you can actually send things in. It's actually most popular for a lot of web servers. It's the back end where you could actually store all of your data and then do analysis with it with a web front end. Oh, here's the order forms, or here's this data that comes in that way. It's very powerful. I actually teach several classes in MySQL, and I think the end of the semester, all the students are like, wow, I could actually do all my finances. I could do this, do that. Yes. Another popular way to actually do a lot of the mathematics is there's a programming language called Python. It is free. You can load all of the development and type of things, either on, in my case, on a Mac, on a PC, on any environment. It's all open source type things. And there's all kinds of libraries to do moving averages, to do various correlations that allow you to expand much, much bigger than Excel can do. And of course, Excel itself has all these free extensions if it's a math problems that you're trying to, you're limiting you, as compared to too big of data sets. I mean, we actually have run analysis that crashes Excel because it runs out of memory again and again, where we have to find another way to do it. So when it comes to the activities that I do, I clearly use Excel for quite a bit of that. When it comes to the other aspects that we're not really touching here, which is using machine learning and various aspects to be able to do deeper dives in each of these. Traditionally, that answer is Python, because that is sort of the de facto standard for prototyping AI and machine learning type approaches. So I typically bounce back and forth to Python for most of my analyses. It's fairly convenient. And once you've learned it, it's not so bad, but make no mistake, it is an actual programming language. R is an interesting language. R is not as well supported as Python. One of the things that I traditionally do, for instance, I set up a flight simulator and was actually doing regression analysis against vibrations of the engine and engine failures. And I could do everything in Python except the actual flight simulator. I had to do that in another language because it wasn't fast enough. So I had the ability to do all of my regression analysis, all of my statistical things that I was trying to do, and quickly plot and actually do real-time control of an actual flight, airplane flying. R is not that deep. It's not really meant to that. It's meant more of the data science type things. Now, the answer is if you know R, use it. You can do a lot with it. It's just there's a limit that Python is in effect is basically unlimited. What it can do. R still is not there yet. And as I've been watching the trends of data science, the trend is tending to lean more and more towards Python. So that's where I've been focusing these last couple of years. But I do know R also. I don't use it as much anymore, but it can still do a lot of the same things. And yes, would be another example of way to do
Peter,
analysis. Yes.
Peter, real quick too, about what about Power BI? Because I was starting to use that. And it can, is that not recommended?
No. Okay. So don't get me wrong, not recommended is different, but Power BI traditionally is not free. Okay. So typically there's a cost associated with it in terms of the tools and capabilities, just like that's part of the reason why I was trying to do these that are free in terms of that. I do a lot of programming in SAS. It's a statistical analysis package, and it is very, very powerful. And that's actually where we have to go to when our terabytes can't be handled by other systems. Okay. And yes, it is very efficient, very capable, but it is very far from free. And it's, but it's great. And by the way, you can actually download it as a person and learn it for free. But the same thing with Power BI. Power BI is powerful tool, but it's not free. And what this one was actually trying to do is say, okay, where can we go that at least the acquisition cost is free or basically low cost, that you can get going to get to that next phase, which is, okay, wow, we're doing all these things. Oh my gosh, we still need more. And that's where you actually go, where can you get above and beyond there in terms of, do I need to invest in a Power BI, a SAS, or other capability? Do I hire someone to come in and do an analysis, for us to be able to decide which way should we go? So based on those, that's why I say, okay, where can you get help if this as you're looking at these things? Clearly, Sonoma State. I mean, not just these type webinars. There's a lot of courses that take everything we just did and expands it out so you can help get that understanding. There's a lot of dynamic professors in terms of, hey, we've got these questions on doing accounting. Well, great. There's a whole staff that can be able to do that. And as we kind of indicated, there's a bunch of commercial products out there. We've been bouncing around some of them and talking about, they're not free, but all these tools have value. They also can be integrated into other portions, not just wine sections of, acquisition, purchasing department, ordering department, warehousing solutions. So there are tools that can handle much more, but obviously they cost. Excuse me, and it's not a question of them being able to show their value, but traditionally, if you're asking these questions now, you're trying to get things started and to be able to go to, the winery owner and saying, hey, we want to go spend $50,000 on a SaaS solution or this integrated, BI solution. They're going to tell you no. And it's just disappointing. Whereas on the other hand, if you're like, hey, this is what I did in Excel, do you mind if I do this? Or, hey, can I spend a little bit of my time doing this and building that more slowly? The idea is being able to understand that. Yes, you can actually say, okay, I want to spend that $50,000 to go do